Great, this is chemistry lesson 7.02 over writing the names for covalent compounds. You'll notice it says covalent / molecular. Remember, the smallest piece of a covalent compound is a molecule. So, smallest piece of a covalent compound, covalently bonded compound, is a molecule. Now, we'll get sloppy and we'll refer to lots of stuff as molecules. So we'll look at sodium chloride and we'll say a molecule of sodium chloride. Technically, that's not correct. The only thing that has molecules are covalent compounds. And it's important also to note that covalent compounds are two or more nonmetals. And in this case, we want two or more nonmetals that are neutral, because what's going to happen is we're going to see later this molecule can pick up an extra electron or two, and that's going to then put it into the realm of ions. So if you take sulfate and sulfate picks up, so let's say this guy picks up 2 electrons and it becomes SO3 minus 2, which it can do. Now this is it's even though it's covalent, we treat it like an ion. So we treat this like an ion. And we're going to define that in the next video. So we're referring to things that are neutral. And you notice here, there's no sign around it. So my litmus test number 1, sulfur is a nonmetal and oxygen is a nonmetal. So I have 2 or more nonmetals with no charge. So I'm going to use the rules for naming covalent and molecular formulas. So here's how this works. We take the, so let's start down here. Let's start with N2O5. So kind of the formula is you do a prefix, prefix from the table above, plus the name of the first element, the only exception is if there's only one. We don't use no, we're not going to use mono here. So if the first one is mono, you leave this off. So prefix, name of the first element, and then you go prefix plus name of the second element, ending in IDE. So that means we have N2O5. 2 is di. So this is going to be dinitrogen. Di, name of the first element. Dinitrogen. Prefix, the prefix for 5 is penta. Penta, I have oxygen, so I need to change that to oxide. Dinitrogen pentaoxide. Up here, because it's charge, it's neutral and it's sulfur and it's oxygen. I have sulfur. Now there's no number here, so there's a 1. But remember, the way you would use this with the table is you would put mono, but we don't use mono if there's just 1. So I skipped this, and this becomes sulfur. Now I have a 3 here, and the prefix for 3 is tri, and this is oxygen, so I go oxide. And you're going to have to memorize these. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa 8, nona 9, and deca 10. So let's do a couple more samples. Let's do PCl5. Okay, this is going to be, again, I only have 1 phosphorus. I have phosphorus and I have chlorine, which are both nonmetals, so those fit here. I only have one phosphorus, so this is going to be phosphorus. 5 is penta, and I change chlorine to chloride. Chloride. How about this one? All right, now I do have a 2, so that's going to be di. I have di, and the name of my first element is hydrogen. Dihydrogen. And then I have 1, so I have mono, and I don't put oxygen, I change this to oxide. Dihydrogen monoxide, which, as you guys know, is water, but its scientific name is dihydrogen monoxide. So we always start with this. This is the easiest group to handle, and it doesn't really get challenging until you get a mixture. So what if you had a mixture of, let's do CaCl2, and we do CO2, and I do SRO. Well, what you have to do before you start is you have to identify the fact that barium is a metal, so this is going to be ionic. These rules don't apply to this compound. CO2, carbon is a nonmetal, and oxygen is a nonmetal, so these rules do apply, and this is carbon, the 2 is dioxide, carbon dioxide. Strontium, you have to check out where strontium is, you have to check out where oxygen is. Strontium is a metal, so these rules don't apply to that. So where it gets tricky is when you have a mix and you have to decide which set of rules to apply. So I'll have a flow chart for you later that you can use. And the first step is always identify if it's covalent or molecular, and if it's covalent or ionic. And if it's covalent, it's pretty simple. But the trick is, and where you'll trip your toes is you'll forget that we've got 2 different sets of names. So, all right, that gets the ball rolling, and let's move on to naming ionic compounds in the next video.